Okay, guys, today a friend of mine asked me to explain this KC value, so I just decided to do this for you all. This is the question paper that was written in 2019 November. This is the grade 12 question. I'll be doing only the KC value part, showing you guys how to get the KC value. So here is our statement, here is our equation, and here is our statement also continues here. So let's read. Initially, 60.8 grams of carbon dioxide, which is a gas, reacts with a solid carbon in a sealed container of volume 3 decimeter cubed at temperature T. You see that this is the new sentence. At temperature T, the equilibrium is reached. Okay, we got that. So when the temperature is 3, our reaction has now reached its equilibrium. If you want to know more about the chemical equilibrium and all the stuff, please visit your textbook. Okay, at equilibrium concentration of carbon dioxide, which is a gas, is 0, or at equilibrium the concentration of carbon dioxide, which is a gas, is 0,054 moles. Here we've got the mass, the initial mass. Here we got the volume. So what is it that you need to do before attempting this problem? Please firstly get your data there. So we have the initial mass. The initial mass is 60.8 grams. Secondly, we have the volume. The volume, I'd say that the volume is constant because we're using only one volume throughout the reaction, because the volume, in order to get this product, we firstly reacted these using this volume. So if this product comes from this reaction, then here is the volume of that product too. So here we have the volume. This is unlike the acids and bases, where you are going to have the volume of the acid and the volume of the base. So the volume of the container is 3 decimeter. Whenever you are given your data, please make sure that your volume is in decimeter cubed, and make sure your initial mass, in fact your mass in chemistry, must always be in grams, regardless of what is it that you are dealing with, unless you are writing physics. Okay, now here is our data. And lastly, what is it that we have? We have the equilibrium concentration of carbon dioxide. Equilibrium concentration of carbon dioxide is equals to 0,054 moles per decimeter cubed. Okay, so now this is all we have we are required to calculate the Kc value. What is it that you need to know about the Kc value is that the Kc value is the product, is the concentration of the product over the concentration of the reactants. And in this case, we have the concentration of what? We have the concentration of one reactant. That means there's a lot of work we need to do. So what is it that is left now? The only thing we need to do is to simply draw our table first. You draw and label, and keep it in mind that this will never ever be given at the formula sheet behind at the back of your paper. So here is our table. We've got 1, 2 of the reactants. We've got 2 reactants. We've got 1 product. That means we are going to have 3 columns here. 3 columns. I'm sorry, my marker is giving me problems now. Please make sure that you subscribe so that I can get some money and buy a new marker. Okay, this is it. So here we're going to write this as it is. Do not ignore that 2. Do not ignore that 2, which is the coefficient or the molar ratio. Always write that 2. You are going to write 2 carbon, 2 CO, which is a gas. Do write this G. Then now this is your product. Then these 2 are your reactants. Then you have 1, so you can just ignore, write them as they are. Here we have a carbon dioxide gas. Here we have carbon, which is a solid. We have carbon or a solid. Then so now we're nearly there. I'm sorry about my lines. Lines are not that important. They will never make you lose some marks. So here you are going to have your initial mole. Initial mole. Here you have your initial mole. Then draw a line. Secondly, you have the mole formed. The mole formed or lost. You have the mole formed or lost. I will try to explain these, or try to explain how can you keep them in mind so that you don't forget them. Thirdly, you have your mole at equilibrium now. You have your mole at equilibrium. Then after that you have the concentration. At equilibrium, not just the concentration, but the concentration at equilibrium. Okay, again, so let's try to put this to apply this in real life. Let's say you are carbon. Let's say you are carbon, or you are carbon dioxide. It's you to choose. So you are going to school, right? You are going to school, and when you go out, your parents don't have money to give you as the pocket money. So you go to school with nothing. Then when you get to school, remember you have zero money, right, at first. But when you get to school, your friend has got 10 rands. Then he or she decides to give you 5 rands. Maybe he decides to give you 5 rands. So now there is the mold that is formed. You have gained something. This is the mold gained or lost. So you have gained the money and he or she has lost the money. This means that one has lost and one has gained, or one has formed. Yes. So this is before break time, when he or she was giving you, when the exchange process was taking place. Now it's the break time now. When it's the break time, during the break time, everyone is equal now. Everyone is going to the shops, get some snacks. This is where we get the mole at equilibrium now. We all equal. Nobody can see that you don't have money or you didn't have money at first and all the stuff. So that is how you can remember these. I believe that I used to remember them like that when I was still doing grade 12. Okay, so this is what you must know. Whenever, wherever, the mole initial of the products is always 0, will be forever always be 0. So immediately after completing this table, simply put your 0 on the products, because at the beginning of the reaction, these products were not there. These products were not there. When you were fighting with your mom or your dad, asking for too much money, your friend was not there. Your friend had no money there. Got that? When you were busy fighting with your parents and you ended up getting that 10 rand, while your friend has got 0 rands. Now when you have 10 rands. Okay, so now let's come back to our data. We have the initial mass. We have the initial mass of carbon dioxide. We have the initial mass of carbon dioxide. So in order for us to get the initial mole, of carbon dioxide, we need to use this initial mass of carbon dioxide. Here is the formula. Mole. Number of moles. Yes. Number of moles is equals to is equals to mass over molar mass. Mass over molar mass, or atomic mass. So you have your mass there. This is your mass. You have your mass. Your mass is 60.8 grams, all divided by, you simply go to your periodic table, as I am going to my calculator right now. You go to your periodic table and look for the molar mass of carbon dioxide. You are going to have 2. This 2 is this 2. You have 2 oxygens, so you are going to have 2 times what is the molar mass of oxygen? It's 16. So you are going to multiply this by 16, then you write plus. You write plus. What is the molar mass of carbon? I think it's 12. I think it's 12. Then you simply punch that on your calculator. You simply punch that on your calculator so that you can simply get your answer before the time ends. And please do not pretend to be a genius or do not try to act cool. Just simply punch that on your calculator. So it's 60,8 all divided by 2 times 16 plus 12. Then your answer is 1,3818. And please, when writing the number of moles, do not round off to 2 decimal places. Try to round off maybe to 4 decimal places. So this is your number of moles. So you have your mole initial now. Your mole initial, then you take that, you write it here from it's going to be 1,3818. Again, we're not done yet. What about that? Oh, the one another thing that I've forgotten to write is that, or to tell you guys, is that the mole formed or lost. Okay, let's leave it. Let's leave that. Let's again go to our data. Here we have the volume. Here we have the volume. Here we have the concentration. Now we have the concentration of carbon. Now we have the of carbon dioxide, and also what? And also the volume of carbon dioxide. So we simply take that concentration of carbon dioxide and plug it here because it's already given. So you have a 0,0554. You will never understand this if you are not practicing it. You will never ever understand. I can assure you that. Okay, so you have now your concentration of carbon. You have your initial mole of carbon. That means there's a lot to find here. So now let's simply use the the formula. It's there at the back of your question paper. It's N equals to, no, it's C equals to N over V, where V is the volume, where C is the concentration, and where N is the number of moles. So now we are looking, as I have said, that even the statement also stated that at equilibrium, the concentration of carbon, that means using this concentration, the only mole of carbon that we can get is the mole of carbon at the equilibrium after carbon has lost some moles or gained. We'll never know. So now let's calculate the number of moles of carbon at the equilibrium. So let's quickly play around and solve this. So you know that there is a denominator of 1 here, so N multiplied by 1 is going to be N equals to CV. Then the number of moles at equilibrium are equals to the concentration at equilibrium multiplied by the volume. So here is your C. What is your C is your concentration. Here is your concentration. You have your 0,05. You have your 0. 0.054 multiplied by the volume, multiplied by that volume, which is 3 decimeter cubed. Then you multiply that by 3. Again, you quickly go to your calculator. What is 0.054 multiplied by 3? This is equal to 0.16162 moles. So here you have 0.16162 moles. Oh, we're nearly there, aren't we? This is what you had before. This is what you had before. This is what you are left with right now. You get that? This is what you had, and this is what you have. So what is it that you are? The only thing to determine what you have lost or gained is to subtract what you have right now from what you had before. That means you are going to use the formula mole initial minus the mole at equilibrium, so that you don't get a negative answer. Or you can even you can even subtract this from that, but always subtract the smaller number from the bigger number whenever you get here. This has got no formula. So 1,3818 minus 0,162. What is it that we get? We get 1,2,1,9,8. Yeah. So what you must know is that whenever you reach this row, this mole formed or lost row, the only thing that matters is the ratio. The only thing that matters is the ratio. You are not calculating, you are just applying your math, I would say. So here you have the molar ratio of 1. Here you have the molar ratio of 1, but here you have the molar ratio of 2. What this means? This means that the mole that is formed or lost by carbon dioxide is the same as the mole that is formed or lost by carbon. So here, since the ratios are the same, you are simply going to just plug this number this side. You are going to have 1,2,1,9,8. We're just plugging. So now, in order for us to get the mole that is formed or lost at the equilibrium, the mole that is formed or lost here, the only way to find it is to multiply this by 2 because of that ratio. So we are going to punch 1,2198 times by 2 on your calculator. Let's quickly do that. 1,2198 times by 2 is going to be 2,4396. Now, what is it that is left? Aren't we done? No, not yet, but we're nearly there. So you had 0 rands when you got to school, right? But when you are at school, your friend decides to donate a 1 rand, a 1 rand to you. So now, since you had 0 rands, then your friend decides to give you 1 rand. So how much do you have now? During the break, how much do you have? You have that 1 rand because you had nothing. Therefore, you are simply going to take this and plug it here. You have 2,4,3,9,6. That is 6. I'm sorry. That is 6. What's left? We don't know the initial mole of carbon. We don't know the mole at equilibrium of carbon. So since we don't know these two, there is really no need to waste your time thinking where you are going to get this. Just go ahead filling those spaces that you can fill faster. So now let's calculate the concentration at equilibrium of carbon, of CO. So how can we get that? Okay, let me create some space. Let me try to click here. Now we're looking for the concentration. Let me clean this also. Now we're looking for the concentration at the equilibrium. You have your C. This is your concentration, equals to N over V. So this is equals to, what is your N? Here is your N. This is your number of moles at equilibrium. That means you're simply going to write, you're going to have 2,4,3,9,9,6 all divided by, what is the volume? Your volume is 3 divided by 3. This will be equals to what? This will be equals to, we don't know, so let's quickly go. I suggest that if each and every thing you are doing on the exam, please punch it on your calculator. 2,4396 divide by 3, then this is equals to 0,8132. This is the concentration. And then in moles per decimeter cubed. So you know the units. Just take that and plug it here. You have your 0,81332. And please do show all these workings, even those we've already wiped it, but please show them because your marker needs to see your workings. Okay, so we're nearly there. Now let's take a look and see okay guys, as I have said, so what is it that is left? We have filled this side, we have also filled this side. We are left with this side now, and we don't have the mole at initial, we don't have the mole at equilibrium, we don't have the concentration at equilibrium. You know what causes this? When you are calculating the Kc value, we don't consider the solids. So the reason why I didn't tell you this at first is because I wanted to prove it to you guys that you will never ever get it. Got that? So if I were to tell you, I would say just forget about this part. Forget about this part when calculating the Kc value, because this part is the part for solid. We don't consider this. We consider only gases and aqueous solutions. Yeah, aqueous solutions, we consider them. We don't consider solids when calculating the Kc value. So now we can simply and quickly calculate our Kc value right here. What is our Kc value? Kc formula. Kc is equals to the concentration. Don't forget to write these square brackets. These square brackets means okay, we're not there, but please make sure that you put them, because if you put some sort of round brackets, then marks will be deducted. So this is the concentration of products all over the concentration. These square brackets are the ones that tells us that this is the concentration we are dealing with. The concentration of products over the concentration of reactants. Please make sure you write these square brackets again. Now we're nearly there now. Here is the Kc value. So what are our products? Here is our product 2CO, which is a gas. Then when you write that, you have to recall some logarithm laws. The coefficient becomes the exponents. The coefficient becomes the exponent in this case. So you are going to write your square brackets and close them. Then on the inside you are going to write CO. Then with the exponent 2, you have CO squared, just like that, all over carbon dioxide. You are going to write this carbon dioxide as it is, carbon dioxide, close that. Do write this so that you can have some kind of accurate work. So now you can remove the square brackets. You can remove the square brackets since you are about to substitute numbers. So this is the only part we are dealing with, the concentration part, the concentration at equilibrium. So this is the concentration of our product, which is 0.8132. Then you square that. Remember, you have that exponent, which is 2. Then you square these 2. 0.1832 all squared, all divided by 0.0554. Therefore, your Kc value at temperature T will be the product of that. So now again, let's quickly go to our calculators. I don't know if you don't have a calculator. I don't know, but I will quickly go to mine and punch that 0.8132 all squared 0.054. When teachers are marking Here we are going to have 12, comma, 2, 2, 5. This is your KC value. This is your KC value. The KC value do not have units because you are dividing the concentration with the concentration. That means the units are going to divide, and then you are going to have one. We are going to simply have the number 1. So guys, please let us know if you did enjoy this, and please make sure that you don't forget to subscribe, like, comment and share, and please turn on that notification bell so whenever I think of dropping something, you can be always notified. By the way, I wish you all the best on your exams, guys. Hopefully you make it. Thank you.